Thank you. Hi, everyone. Welcome to my talk, which is going to be about, my name, just let me introduce myself. My name's Matt Watkins. I'm a senior lecturer in robotics and computing here in sunny Falmouth in Cornwall, right at the far end of the UK. And what I'm here to talk about is, of course, I'm going to talk about programming because that's kind of what I do as part of my day job. But I come from quite a kind of a varied and hybrid background. I'm Cornish. I'm originally from Cornwall, but I lived in London, Manchester, Nottingham, a whole range of other places, and traveled the world. Really combining my interest in computing, but also in creativity. So I started off as an artist, and now I'm a programmer and an engineer. And so I've kind of had um, a mixed career in terms of cross weaving between art and technology, art and computing. And so I kind of want to talk about that as a particular skill and a skill that's particularly relevant in today's climate, in today's world. So what I wanted to kind of start with is kind of to look at this thing about creativity computing. Quite often, perhaps at school, there's often a divide between who does art and who does science, and this is a problem area. This is from somebody at Stanford University who said the divide between art and science is a mistake. The division between art and science division is embedded in our culture. We think of science as exact, objective, following a strict method, whereas art is creative and subjective with no formal rules. But this picture misunderstands what actual science looks like. So one of the core points that she makes here is not even the logical core at the heart of science can escape artistic thinking. So what it's saying is that even a scientist doing their most objective experiment is always making a decision in their head about a creative choice about whether they do this or that. So it's kind of really important that we kind of think about the kind of fusion between things and not to think of things as one being highly logical and one being illogical or irrational. And in fact, this poster here is from a 1968 exhibition called Cybernetic Serendipity, which was essentially an exhibition of artists who are making robots, who are making all sorts of computer kind of generated materials very early on in the kind of history of computing, if you like, in the sort of late 60s. So it is possible for these things to be fused. And so I'm going to take you back to a little bit back to the kind of 80s. Which is kind of when I was growing up as a teenager, and the kind of 80s and 90s music scene, the kind of rave scene of kind of electronic music that was coming from America, primarily from kind of areas like Chicago and Detroit, and that was feeding into the UK, feeding into a kind of a slightly kind of how could we describe it? A kind of a raucous youth culture that was developing. And this young culture didn't want to follow the existing rules. They wanted to break out of those rules. So they started going to places where they maybe shouldn't go to warehouses and start setting up sound systems and playing music, and then also applying their own DIY approach to how they created music environments. So not only were they creating their own music, but they were also creating digital visuals and a whole range of other things. And most of this was being generated from the new technologies, the new synthesizers that were coming from Japan and other things that were happening. And this was a kind of real sort of change in the way that people consumed culture, that rather than kind of waiting for it passively to arrive, they would actually be making it themselves. And that now is kind of a dominant part of our technology. So we also start to see in the 90s this kind of real kind of groundswell of creative computation, the idea of a whole load of tools that allowed a lot of people to start making stuff on their own, whether it was art, so 3D kind of art was beginning to come around, music, as I've kind of discussed, but also other things were beginning to happen, like VR. But there's the picture in the top left here is a very kind of early example of that. And also we have got big companies like Apple, which are really encouraging the creative market to get involved with using computers. Up to that point, it was people a bit like me, nerdy guys working with computers. So they were kind of trying to encourage people who weren't from traditional computing backgrounds to start using computers. So these kind of tools and software were emerging. And we kind of consider this, or I consider it, the creative computation moment, the moment where people start to take over the tools and start using them themselves. Now, what I'm going to do is suggest that there's another transformation which has happened in recent years, which is what we call computational creativity, which is an emerging field of research within AI more specifically, so artificial intelligence, that focuses on the capacity of machines to both generate and evaluate novel outputs that would, if produced by a human, be considered creative. So in a way, what I'm referring to now is this idea that machines can also be creative. They can make things that we can judge as being creative. And in fact, if the video playing, which it might do. There we go. So in this example is by William Latham from 1991, and this is an early kind of generative computer system which is generating these kind of really interesting forms, and a lot of kind of aids. So coming back to the kind of nightclub thing, a lot of William Latham inspired a lot of kind of people who are generating visuals in nightclubs at the time, and so we kind of get these kind of quite kind of interesting, organic, but slightly kind of trippy kind of visuals were kind of developing as a kind of response. And William Latham was an artist who wanted to create kind of generative artwork, and this was kind of his contribution. He also went on from that to he created The Thing in the computer game, which was based on the original film in 2002. Because of his skill at creating these kind of generative things, made him very good at creating a kind of monster that's kind of generating sort of weird and kind of terrifying kind of effects. So computational creativity requires a machine to perform both pattern generation, but also something that introduces an element of randomness to the process. And that's what we humans call creativity. I'm taking from a quote from Bob Ross, who you may or may not know about, but is famous for kind of painting these slightly chocolate boxy kind of saccharine paintings, but with an incredibly kind of joyous kind of approach to it on television. And he said there are no mistakes, just happy accidents. So one of the things that we often associate with computers is this kind of a sense of kind of being very rigid and binary and very kind of specific and logical, whereas what we're interested in humans is this kind of happy accident mode, doing something that suddenly something happens which you weren't expecting. So one of the ways we can think about that in computation is to go and look at something like quantum, or look at the idea of something which is a bit variable. So some of you may have heard of Schrodinger's cat, which is a thought experiment that demonstrates that some of the fundamental principles of quantum physics, a cat, a flask of poison, and a radioactive source are placed in a sealed box. If an internal monitor like a Geiger counter detects radioactivity, the flask is shattered, so if a single atom is decaying, the flask is shattered, releasing the poison which kills the cat. Quantum mechanics implies that after a while, the cat is simultaneously alive and dead. Yet when one looks in the box, one sees that the cat is either alive or dead, not both alive and dead. This poses the question of what exactly quantum superposition ends and really resolves into one possibility or the other. So what I'm implying here is this idea of quantum, the idea of a quantum universe is a universe where everything could possibly exist at the same time. The cat is dead, it is also alive. So this is this kind of idea of Schrodinger's cat. And so this is kind of interesting thing that we can apply in computing. So waveform collapse is a kind of emerges from quantum mechanics, and it's all about waves of light passing through a card against a light, and the fact that this interference that happens. But we can create images using the principles of this waveform collapse. So this is an experimental thing which has now been developed, which basically allows this kind of quantum nature to be embedded into the way that we might generate something in art. So more specifically, in this example here, it's how we generate a kind of an environment in a game. This is kind of quite a basic graphics, but you can see here that the computer itself is generating using a kind of random thing based upon quantum to generate different terrains. Now this is a kind of simple version of it, but I've seen this now being used for full 3D kind of rich, textured and lit environments where we can use this. And you can see here what's happening is the computer is creating something, and then some things can be fixed, and then the user can actually change elements that they choose. So there's a kind of idea of a collaboration between both the human and the machine going on, so that the machine is kind of creating this kind of using quantum, it's becoming slightly more creative in its approach, but then the human can actually choose if it likes something or not, and then move on. So there's this kind of idea of collaboration between a machine and a human. Um, this is an example which is taken from the same principle of wave function collapse to generate houses for a game. So this is a kind of, you can build your own kind of islands. And it was actually taken from a game, and this is being used a lot in game development because it's got a quick way, particularly with an established game. If you want to develop new levels, you can have this kind of way of generating a kind of an environment completely from scratch, but also copying a kind of similar look and using these kind of techniques. So the other thing that is being kind of happening as a result of things like AI, which allows us to develop a whole range of kind of different ways of doing things. So the AI makes choices that we wouldn't normally expect. And one of these things in robotics we call the sim to real is this idea of like, how do we go from a simulation, say a virtual environment, to the real? How do we go to something which is an actual machine? And we're seeing this developing a lot in engineering. Is engineers will develop stuff, or designers will develop a certain thing, an object, a shape, and then in order to kind of resolve a problem, they'll let AI fill in the gaps. And so we're beginning to see certain components. We know it's happening in the building of certain engine components. Actually, we're allowing the machine to work out the spaces that the designer's struggling with and see whether they can create interesting elements. And something at Falmouth, we're getting a load of equipment related to this so that we can develop whole systems. We've got a series of robots which are going to be able to build and 3D print objects. And we're also getting kind of virtual environments for people to be able to kind of sculpt in real time in a virtual environment, and then allow AI to contribute and then actually print out and make their own parts and components. Another kind of interesting area, and this is kind of more purely sort of art-based, this is by an artist called Ian Cheng, who made a thing called Emissaries. And this is where it's essentially an artwork that you watch, but it's also a game. So this is a world full of computer characters who are constantly in kind of interaction with each other. And you just kind of watch it as an experience. But it kind of evolves. It's like a whole civilization, a little bit like watching a kind of like a game of Civilization or similar kind of big world game. But you kind of watch as player characters fall in love, as they kind of fight wars, as they do things, and you kind of observe this thing. And it's all powered by AI. All the agents have kind of artificially intelligent behaviors, and it develops. So kind of interesting where we're seeing kind of games beginning to kind of enter into art galleries. And so this kind of intersection between using art, using game tools, game engines to generate art, which is being shown here. So in the Museum of Modern Art in New York, we're beginning to see this intersection, so creativity and computation as one. So that kind of brings me on to, so I'm a lecturer senior lecturer at Falmouth University. So I'm going to kind of quickly give you sort of talk a little bit about also sort of what happens at Falmouth University, so you get an insight into that. So we have a new course, Creative Computing, which I think is kind of an opportunity for students to look at these particular interesting intersections between art, between games, between design, between engineering, all sorts of areas between theatre. So the idea of using computation to generate kind of virtual elements that might be part of a theatre experience. We're seeing a lot more immersive theatre emerging as a big thing, particularly in London. And other sort of major cities where they use fusing sort of VR technology with real-time actors. So we're kind of very interested in this kind of exploring this area here at Falmouth. So kind of just to kind of, so I'm primarily a robotics lecturer. And so just to give you a kind of further example of where we're using creative computation, this was an exhibition at Falmouth Art Gallery, who have one of the world's biggest collection of automata. So down in the bottom, in the middle there, is an old automata. So these kind of models that you turn a handle and they kind of perform, and they're kind of famous. There's a famous artist called Spooner, David Spooner, who made a load of these kind of automata, and they wanted to kind of bring that right up to date. So they got students in my robotics department to build some machines. So one of them on the left here is a kind of beautiful kind of prism, which as you move around it kind of shines a light in different directions all over this kind of prism and creates these kind of illuminations all over the wall of the gallery. And then on the right hand side is a machine which scans your face and then does a drawing. But what it does is it plays a little game in that it isn't a kind of traditional drawing. It takes points on your face and then tries to kind of create a new picture. So it kind of creates these slightly kind of expressionistic images you can perhaps see if you can see in the right-hand side there. So these are these kind of interesting experiments that students conducted. So kind of fusing this idea of an art space, which has then got engineers in it, robotics students conducting things alongside traditional artworks that you can see here. So I'm going to quickly tell you a little bit about Falmouth as well. So this is a little overhead shot of Falmouth. We're a beautiful town in the far west of the UK. The whole of Cornwall is famous for mining, but perhaps more recently it's famous for holidays. A lot of people in the UK come here. It's world famous for surfing, for beautiful cliffs and large waves and sort of beautiful coastline, fishing, and what have you. So it's a very kind of beautiful place to study. This is our main campus. We have two campuses, one in Falmouth and one in Penryn, but this is the main Penryn campus. We have a number of courses. So we have undergraduate courses. So I've mentioned creative computing, but we have game development programming, artificial intelligence, computer science, computing for games, immersive computing, robotics, and software engineering. And what we prioritize is that we don't really care where you come from, but we want you to learn how to program if you don't know. We have some students come to us from computer science backgrounds. Some students don't come from such backgrounds. But programming is a process of taking or designing an algorithm and then encoding it into notation so that it can be executed on a computing platform. So programming can take you into lots of careers. I mean, it is a kind of key component. I know some people might say that that it's threatened by sort of AI tools, but it's still an important thing. The best programmers, even if they are using an AI tool, still need to know the fundamentals of programming. It does involve maths, and that was a problem for me to begin with because I came from an arts background and my maths was not brilliant. But it's a different kind of maths, and it's logical and applied, and we support and help you. And actually, a lot of people can learn a lot of maths in the right conditions, especially when they can apply it to their own application and make sense of it. So computing is more than just code. We emphasize the idea of being a computing professional because what we're interested in is it's also about learning to identify and explore and solve problems, harness technology to address complex multidimensional challenges, and to collaborate with people, to exercise creativity in designing experiences with people, designing underlying platforms that enable such experiences to exist, to define, collect, analyze, and visualize data to inform decision making. So there are so many kind of elements to being to working in computing, to being a professional, and it's not always this kind of this perception we have of the kind of nerdy programmer, but programming, it's a huge area, and there are so many sort of avenues that people can explore within the world of computing. Here's some examples of some stuff that has been done here. So we have been doing a number of different projects working with the fishing community. We've done projects working with, we've built a VR experience of a pirate ship in the North Cornwall. We've also been doing experiments where we've created a kind of AR, VR experience of the whole mining, because Cornwall is full of mines. And so they've used LiDAR scanners to scan the mines, and then we've kind of turned those into visualizations for people to kind of experience the mines, even if they can't access them. So we've kind of been looking at technology in lots of different ways. This is from a third-year project where they wanted to, a third-year robotics project where they identified that one of the problems, one of the boring and hard tasks in say exhibitions or conferences is that people have to lay out a hell of a lot of chairs. So what if a robot could do that task? So this is their solution, which was a robot that could plan and build a plan and execute a conference stuff. So this is another robot by another third-year students. This was the idea of making a, so as you saw in the first scene, that was the original prototype, was they were going to make a thing which could scan over crops using ropes, a bit like those sky scanners that you get at football matches, which can kind of fire a camera across a football pitch. This is the same, but for crops. So this was a project that they worked on, which was worked in collaboration with the local kind of agricultural community here. Also, we're applying this computing in games. This is a very beautiful game from a few years ago that a student built. Hopefully you can hear me over the sound of it, if you are getting the audio coming through. But this is a beautiful game where, although it looks great, there's also a lot of engineering and computing in the background to build complex pathfinding methods for this plane to move very effectively through the environment. So it has this beautiful motion because it path finds from one point to another point, and it keeps the motion smooth. So, we're interested both in how we apply this in real world, but also how we make beautiful things that are engineered to perfection within kind of virtual worlds, like within games. So we cover a whole range of different things. I mean, I won't go into every single thing in this session, as I'm aware of time. But we have a curriculum that deals with all sorts of programming languages, all sorts of algorithms, and a whole range of different things. So why would you study with us? Well, we have this because Falmouth is an art school embedded in a 120 years tradition of art as well as technology. We're leading a leading light in the world of computing, particularly in games, where we're considered to be the second best university for games production in the UK. But one of the other things is you may be aware that $600 billion is being spent on the AI industry. We don't know exactly where that's going to go, but currently it's turning into things like this, huge data centers. And that potentially presents a threat to us. And many people, a lot of the news is full of negative stories about AI, and we can feel kind of anxious about it taking our jobs and all of those kind of ideas. Things like large language models like ChatGPT and large image and video models, which are beginning to generate these kind of videos from Mid-Journey and the like. But we also have to put it in context. A recent study shows that 80% of companies that tried using generative AI have found no significant impact on their bottom line, i.e. it wasn't really making them money. And 42% have literally abandoned all their AI projects. And also the MIT study found that 90% of AI pilot projects at big companies failed. So it's a really important thing to think that it isn't all doom and gloom. A lot of the companies are realizing that all those people that they may have laid off recently, that maybe that was a bit hasty. But what we're interested in AI is thinking of it as a tool. How can we do that? So what we in our courses here, we harness that by getting you to learn how to program neural networks, to do things like supervised learning, which is kind of like using cameras to kind of be able to train it on identifying objects, or reinforcement learning, which is things like I've been showing students how to learn how to train a robot so it can walk. So they're kind of interesting, very practical applications for these tools, and they're not just all associated with the bad stuff, if you like. So one of the other things we do at Falmouth is we call it doing it for real. So we emphasize creativity, so focusing on design and lots of divergent and subversive thinking, getting you to think of new ways of doing things, and rapidly prototyping. We also think about the technique. How do you program? How do you make use of different things by using engineering and maths and fabrication, but also thinking about how you have a pipeline, a workflow, how you use certain techniques like agile to work in teams to deliver projects. And application, so multidisciplinary approaches, how we get lots of industry briefs, as you've seen some of the examples I've shown you, and you work a lot in teams. And so this is continuous iterative approach of doing this all the time is our idea. Get doing it for real, constantly try and apply your learning as quickly as possible. And that comes from this idea of working in teams. I know I only have a very short amount of time, so working in teams is a critical part. But we also have a big expo, which is like industry event. So it's like both technology, so it's like a technology event, it's like a games expo. We have lots of industry partners coming from Sony, big areas. And so our idea is that it gives students every year an opportunity to showcase their ideas, to show them to industry, to show people, to show the public, and to test their ideas in front of a live audience. But it's also that's a lot of fun. And they get to talk and get kind of tips on how to improve their work. So yeah, as I said, we are ranked as 10th in the world in the Princeton Review and 2nd in the UK. We also have a heavy area of research. This is a recent research we've been doing on a robot camera which is picking daffodils, which is a big thing in the UK. So I will begin to wind up because I appreciate that we are coming to the end. We have a lot of industry briefs from people like Rockstar. We have a local company called Engineered Arts who make humanoid robots, but also other. We have a robot boat company as well, which has given us briefs and so on in the past. So I will skip forward, but also maybe in a final thing. I won't go into some of the elements here, but in a final thing, I just wanted to kind of say that we are also a member of the BCS, which is the Chartered Institute for IT, which means that we are kind of recognised much like many of the Russell Group universities, as providing a high level and a very high quality of computing education. So I think I could show you all of this, but I'm sure if people are interested, I can talk more about
I'm Josh Beckett.
some of the things that we do in the university. But I'll leave that up as a final screen because I appreciate we've now reached 9:30, and I will begin to wind up. But thank you very much. I hope there were some interesting elements within that talk.